Hi to everybody. So here I will do the next chapter about the real-time operating system. I hope you are fine. So this time I make a recorded video I send you so you can perhaps see it often time. Okay. So now we're gonna talk about the different concepts of real-time operating systems. Okay, so first, what is the difference between an operating system and a real-time operating system? So first, as I said in the real-time course chapter, a characteristic of real-time operating system is that it have a predictable response time to an external stimulus. So that is very important. That is make the key difference between a real-time operating system and an operating system, okay, is the predictable response time to an external stimulus. So that means that an RTOS must be deterministic, okay? I already talked about this, but that is the main key topic of a real-time operating system. So in a real-time operating system, at the difference at operating system where you can have threads or tasks is that each task have a priority number and there's a priority between the different tasks. Okay, that is not the case. For example, the difference between a Linux not real time and Linux real time. The one of the thing is that in the Linux real time, there are some priority to each thread or each process. Okay, that's the biggest difference between Linux not real time and Linux real time. In the industry, we consider that an operating system is a real time operating system if the context switch, I already talked about it. The context switch is when you're going to change from one task to another task. It's less than 10 microseconds. Okay, that is another consideration about a real-time operating system have to be very speed. Okay, to context switch because it switch all the time from task to task, and it has to be fast. And the response time also, the interruption time has to be less than 10 microseconds. But it depends also from the hardware. Okay. Why a real-time operating system? Because as we see on microcontrollers, you can write some event-based code, a firmware without a real-time operating system. Okay, you can write some initialization, a main loop, a while loop, and then some interruption that is called event-based programmation. Okay. Why a real-time operating system? Because most of the time, 50% of embedded systems are made of homemade software, what we call roll your own, okay? They do not promote reuse. The thing is that when you write a code for an application with this solution, it's difficult to write another application with some part of this code because it's very specific to this application. Okay, with the real-time operating system, you can reuse from the software point of view, can be done at several levels. You can reuse something for task management, priority scheduling, interrupt management, time management, inter-task communication management like semaphore, message queues, we will see it later, and also the memory management, the memory protection that are given from the real-time operating system. If you don't use a real-time operating system, you have to do it by your own. And most of the time, you cannot reuse it. So for each new project, you have to consider these different things. Okay, here we have a list of recognized real-time operating system. Here, commercial one and open source. So the most famous operating system in embedded systems is VxWorks, but is now a part of Intel. Intel, I think you know, which make a lot of processors. Intel, okay. VxWorks is now by Intel, but I think, my remembering, because there was buy by several companies. Now it's by Intel. It's very popular. What in the Western world? I don't know in China, but in Europe and in America, for car industry, for the automotive industry, and for the aeronautics industry, is very well used. Then you have another one is Micro COS 2, Micro COS 3, Micrium from Micrium is also a very popular RTOS. All two, and then you have QNX. This one from Canada. This one is also from Canada. QNX team makes the operating system for a famous phone company, and I don't remember. It doesn't matter. This is most used in a health system. Then you have Lynx OS, OSE, RTX, etc. You have a lot. There are several hundred different commercial real-time operating systems. They can be used for very specific fields of application. There's Nucleus. Then you have the open source. So I already talked about some of them. FreeRTOS, EmbedOS, Zephyr, ContiKey-OS, Nutix, Phoenix, AirTems, Riot, RT-Thread. That is from China. So perhaps you can look at this. Xenomai, Quark TS, Zephyr is here, sorry. Okay, you can find a complete list here, okay, with some links of the recognized real-time operating system. This one, all the open source. The thing is that more and more the people go to open source solution because it's free, it's a community-based, etc. So here I introduce Micro-C OS 2 from Jean-Jacques Labrosse. He's a Canadian guy, okay, and that's a very famous book. I learned real-time operating system in this book. I've read this book. It's a big book. It's a 1,500 between 500 and 1,000, 800, I think, 800 pages, but very pedagogic. Okay, it's very good with a lot of schematics, and I used a lot of his schematics in my course. Okay, the old one is created in 1991 by Jean-Jacques Labrosse, so it's perhaps 30 years now. Is a commercial product in 1998, okay? And Micro-C OS 2 is an acronym for Microcontroller Operating System version 2. And now there's also the version 3. But this one was very popular since 2010, 2015 is lesser popular, but it's a good one. And because I use a lot of schematics of him and I learned, so I present it to you. So Micro-C OS 2 is a real-time, deterministic, high portable, and configurable multitasking kernel, okay? So deterministic, you see the word, real-time, highly portable, that means you can use it on several architecture. Configurable, multitasking, you can use multitask. Is not open source, Micro-C OS 2 is not open source, but it provided with its source code, okay? You can use it for free for teaching, for the education is free. So more explanation about Micro-C OS 2 from Micrium is it can handle up to 250 application tasks, okay? The memory footprint is from 5 kilobytes to 24 kilobytes. It's low. It's a low footprint. At the time, it was very low. It's the first popular RTOS for microcontrollers. The source code is about 5,500 lines written in ANSI C, so it's perhaps only C code. Micro-C OS 2 is certified by the FAA, so the Federal Aviation Administration, for use in avionics products. It was a certificate, sorry, for the DO 178 Bay that are very famous certification for aviation. Okay, it's also certified for transportation, nuclear systems, SIL 3, SIL 4. Is compliant with the Motor Industry Software Reliability Association, MISRA-C, AUTOSAR. There are coding standards for the motor automotive industry. Okay. So here we can see how it is managed. So here you have the hardware, processor, the peripherals, etc. Here you have the HAL. HAL is hardware abstraction layer. Here you have the kernel, etc. That is the operating system. Okay. So you have several files. They are here. The core, okay, the flag, the mailbox, the memory, the mutex, semaphore, task, time, and one.c, what.h. And then you have two configuration file, OS configuration include file, okay? So, and here you have the task, the application task, task 1, task 2, task 3. The application software, your code is here, okay? Here to port for the portability, from there are only three files to change. Is the oscpu.h, the oscpu.asm is an assembly code, and oscpu.c. Okay, that is the three files to change to make this RTOS portable from one architecture to another architecture. Okay, for example, to go from ARM, I don't know, Cortex M0 to Intel 1951. Okay, so there's only this layer that you have to rewrite when moving from one target, one microprocessor to another, from one architecture to another. And so what it's interesting to say here also is that a real-time operating system needs a CPU and a timer. Okay, that is the two things that he needs to have access to port the operating system. In the case of microC OS 2, here there are only three files need to be modified. Okay, so that is the reason why this real-time operating system was ported on a lot of architecture. If you can see here, all the architecture ported for the microC OS 2 from all these company: Actel, Altera, ARM, Atmel, Freescale, Infineon, Intel, Lattice, Microchip, MIPS, NEC, NXP, Renesas, that is Japanese, Samsung, ST, Texas Instruments, Toshiba, and that is all the architecture supported. So you can see it was ported on a lot of different architecture. So that is why also it was very used at this time. Okay, that was for microC OS 2, huh? Okay, very famous, but now lesser famous. Now I'm gonna talk a little bit more about free RTOS. What we're gonna see in this course is open source, so I will talk later about it. So it was created in 2003 by Richard Barry. Okay, he's the founder, but it was a very popular community project, open source community project, and that is the reason why it became so famous. It's open source under an MIT license. It was ported on 33 different architectures, so it was also a lot of architecture. The kernel memory footprint is from 4 kilobytes to 9 kilobytes. That is also very low. The last version is a 10.1.1 consisting of 5 files code in C. The number of tasks is unlimited. It's limited only by hardware computing power, okay, and the amount of memory, but there's no limit. Is the most RTOS most popular in 2015, 2016, 2017, according to the I3E magazine. So it was really popular, but now, since last year, as I said, it was bought by Amazon. So because it was bought by Amazon, today I think the 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 branding and the use of FreeRTOS will go down because the people say, yeah, now it's Amazon. It's sorry, it's owned by a private company, American company. So I think the the um, the popularity of theater will go down in the next year. But I think so. Okay, I will make here. I make a break to not give too long video. So the next part I do it in another video.